Our goal is to build a large 3x3x3 paper lantern which can involve the community in the building process. We aimed to create a process where we would be able to sense and synchronize each other's arm movement. We started making a wearable device to achieve this. For each wearable device, a VR5 tracker or controller is mounted to each participant's right hand on a plastic substrate, along with an Arduino and 3 vibration motors. And a long cable connects all the electronics to a Raspberry Pi computer mounted around the waist along with the battery. The VR trackers capture 3D spatial data. Our software computes this data into deviation distances which is sent out to each participant's Raspberry Pi. The Arduino then actuates the vibration motors based on the commands the Raspberry Pi provides. The total package is wireless and allows for free movement. There are 3 different vibration motors, each placed on a unique part on the right arm to indicate the X, Y, and Z directions of a movement. From the computed deviation data, the difference between your own position and the ideal position is translated into motor voltage readouts and separated for each movement direction. The master's user position is transmitted to the slave users, in our case 3 other participants. Even with their eyes closed, each participant can sense the movement of the master according to the vibrations they feel. Every participant wears the hardware. There are various material possibilities that could be used with this hardware. In our case, we used balloons, a cheap, light, and flexible material. The VR trackers are connected via the Grasshopper plug-in Vive tracker and the Raspberry Pi computers via local Wi-Fi network. After calibration, the computer randomly chooses one of the 4 people as the master. The remaining 3 follow the master's movements to place each balloon. The exact position is found by seeking the point where all vibration motors stop vibrating. During the process, the person who deviates most becomes master instead of being punished for not following the movement as well as the others. The change is applied every minute or so. Deviation is the driving factor within the communal construction process. Due to this natural deviation, the final shapes are similar but not the same. The balloons themselves are not the final structure. They are simply a mold for paper units. A4 sheets of tracing paper are applied to the balloons in an encasing manner. This is a very easy process that requires no professional knowledge, which is also integral to making a democratic building process. The dried paper forms a strong, self-supporting structure without the original balloons. We made an 80 cm diameter bamboo ring and lifted it to the proper height. The build diameter changes with every level. The wearable switches modes when the participant approaches the build area, allowing them, in a similar process as the previous, to find the build diameter accurately without any external measuring devices. In this case, the master is a fixed position. The units are linked using paper mache as well. Once dried, the structure is stabilized and can be lifted as needed to attach the next layer. As each layer is placed, the radius of the lantern increases slightly to achieve the ideal silhouette of a traditional Japanese lantern. The final step is to pop each balloon and remove the rubber left inside. The paper structure shrinks slightly but remains stable, creating a beautiful translucent surface as an enclosure for the light.